So one of the laboratory techniques that we're going to use in the next class is collecting a gas over water. So when a gas is produced, like you can see here below, the captured gas, as you can see in that beaker container or the collection bottle, it's going to be mixed with water vapor, the gaseous water that exists simply because you have liquid water underneath. The interesting thing is that both gases are going to mix evenly, and both gases are going to exert a partial pressure. And so this helps us in the fact that we can use it and use Dalton's law of partial pressures in order to determine the pressure of just the gas that is produced. So specifically, in order to determine the pressure of the gas, all you need to do is take the partial pressure of the water vapor and subtract it from the total pressure that's measured. And so what you'll do, if you know the total pressure, subtract the vapor pressure from that, and that'll be the pressure of the gas that's dry. Now, luckily, the vapor pressure of water, we know it for various temperatures, and you have a chart right below this diagram that shows you all the different vapor pressures at specific temperatures. And so these problems are very easy to use simply because you just have to take the total pressure, subtract the partial pressure of the water vapor, and there's your pressure of gas that you were concerned with in the first place. So in this procedure of collecting a gas over water, the total pressure that's going to be measured is equal to the pressure of the gas that's over the water, but also the other factor that we have to consider is the water vapor pressure. So I'm going to say pressure of the water. Okay? And so in this problem, it tells me what my total pressure is. It's 101.246. And it's asking me, kilopascals, it's asking me to determine the pressure of the gas. So I don't know the pressure of the gas, but what I do know is I know what temperature this is occurring at. And therefore, using the table that I provided to you in these notes, you can determine what the vapor pressure is going to be. So the vapor pressure at 30 degrees Celsius is going to be 4.246 kilopascals. And I just looked that up on the table. All right? And so based on that, I can determine that the pressure of just the gas, ignoring the water vapor, is going to be 97.000 kilopascals.